So the starter motor is just going to turn. But the thing is, we need to push the pinion gear, which is on the starter shaft. We need to push the pinion gear out in order for it to mesh with the ring gear, because we can't have the starter motor touching the ring gear all the time. So what we do is we have a solenoid, starter solenoid, that pushes the pinion gear out so that when the starter motor spins, it will be in contact with the ring gear. Now I showed you the flex plate here and the flywheel there. Both of them have ring gear. Yes, all these cars are going to have a ring gear. They're going to have a ring gear, and that's going to be a big old ring about, oh, I don't know, maybe 88 teeth. Let's just say 90 for fun. So if it's got 90 teeth and the pinion gear has 10 teeth, what's the ratio? 9 to 1 is correct, because the ratio of 90 to 10 is 9 to 1. 9 to 1. Now since the bigger gear is being driven by the smaller gear, let's make sure we're picturing this correctly in our minds. That has 10 teeth. That's an interesting hypothesis. You're blaming someone for someone else's behavior? That's interesting. So let's see, that's 90 teeth right there. How comforting. Hey, I believe we've talked about this. Mr. Via. God damn it. Well, first of all, I'm going to revolve in this direction. So, which way is this going to go? The opposite way. Yeah, this way. Okay, good. So, my point was, if this is turning at, well, I don't know, 900 RPM. Who gave him permission?
I did.
My class.
Yes, sir.
Haram. Haram. Guess how many students I've had go to the bathroom this year? Well, one now. Guess how many students I've had go to the bathroom since I got here 8 years? It's in your notes. What's the ratio? Why would he look to you for permission? That's confusing. Maybe I'm too stupid to understand. What? I'm sorry? 100 is correct, thank you. That's correct. So it's going slower. All right, so the engine is only turning 100 RPM. Why would we manipulate the gear ratio like that? Speed reduction equals what? Snoop.
Reduce speed.
Speed reduction is reduced speed. That is correct. But what does it gain us?
Gas mileage.
All we're trying to do is start the engine, folks. We're not running the engine on the starter motor, right? We're just trying to turn the engine. We're just trying to turn the crankshaft. Yes. Why do we have gears in the first place? Speed reduction equals what? It's in your notes. What are we getting for our? Okay. What? Nope. Can I ask you a question? Why would you ask him for permission?
Because you were busy teaching.
Why would you? Oh, okay. Why would you think you'd go to the bathroom during class time?
Because I can't go because I went to the three, sir.
Oh. Enabler. Enabling behavior. Haram. Anyway. That's what we call a CS move.
Working manipulation?
No. First word's chicken, I think. 20. Which 20 teeth on this, 10 teeth on that. This one's turning this way. Which way is this turning?
The other way.
The other way is correct. Thank you. Now, if this is going 1,000 RPM, what's RPM?
Rotations per minute.
Revolutions per minute. Okay. How fast is this turning? 500 is correct. Thank you. Broke my streak. Okay. Foot-pounds. Foot-pounds is the units we use to measure what? Torque is correct. Yeah, torque. Torque is twisting force. Yeah, it's in your notes. The notes stand as a solemn, permanent reminder that even if you didn't learn it, I taught it to you. Okay, if I got 100 foot-pounds here, how many foot-pounds do I have here? 1,000 times 100 equals 100,000. The speed went down, so the torque does what?
Go down.
So they both go down?
The torque goes up.
The torque goes up is correct. By a factor of 2 to 1. Yeah, so this is going to be 200 foot-pounds. The reason we do a gear reduction is because we want to increase the torque. Why do we want to increase the torque? Because it's hard to turn things, especially things like motors, against compression. Okay. Speed reduction equals torque multiplication. So here's how you do it. First time they ask you, say no. If they really have to go, they'll let you know. It's just a test to see how soft you are. Okay, 1,000 times 100 is 100,000. 500 times 200. Yeah, because I've got half the speed, I got twice as much torque. That's the whole point. Okay, so if I have 100 foot-pounds over here, I've cut down my speed by a factor of 9, so what happens to my torque?
Goes up, huh?
It goes up by a factor of 9. So this is 900 foot-pounds at 100 RPM. So we're turning it slower, but the thing is we've got all kinds of torque. So we can keep turning it so that it's going to have consistent speed as it turns the crankshaft. Doesn't really matter how fast, well it kind of a little bit does, but it doesn't matter how fast. I mean, we could spin it faster, but the problem with spinning it faster is when it starts pushing up against that compression, it's going to go because it's not going to have enough torque. We need to have enough torque to keep this thing spinning. Think of a diesel motor, it's going to have twice as much compression, so what's going to happen to the required torque? It's going to go way up. That's why diesel motor starters are way, way bigger and way, way more expensive. Also, a lot of these diesel motors are going to have air compressor starting because electric motors just can't hack it when you get into really big stuff. Alright, so now we got 900 foot-pounds. That's going to make it so that we can turn the ring gear even with all that pressure. Trying to push the piston up on the compression stroke. It's not going to turn fast, but it's going to turn. Because after all, we're probably not going to start with 100 foot-pounds anyway. We'll probably start with way more than that. So that is the exciting story of the pinion gear and the ring gear. Now, I believe I showed you. Yeah. Well, it's around here somewhere. Well, I don't know. There's Porto. Yeah. I could just keep using it until it goes to sleep. Alright, so over here I got 10. Over here I got 30. 30 like this. This is going this way, so which way is that one going?
The other way.
Opposite direction is correct. So this one's going, well, let's do it this way. This one's going 300 RPM. How fast is this one going?
150.
How much?
150.
What's the ratio, folks?
300.
What's the ratio of 10 and 30?
1-3.
That's correct. Cross out the zeros. 1 to 3. So if this is going 300 RPM, how fast is that going?
150. No.
100 is correct. Thank you. Because the ratio has to be 1 to 3. Okay, so if I say I've got 100 foot-pounds over here, how many foot-pounds do I have over here? Speed reduction equals torque multiplication. Folks, we spent days on this. What? 300 is correct. Thank you. Now, I'll go ahead and tell you. In this class, I'll probably show you 6, 7, maybe 8 ways to make 6 figures when you're 18. But if you ain't gonna do your part, there's not much I can do. You a senior? Did you get a hold of intake yet? What's your plan? What?
It's okay. Like, counseling.
To do what?
HVAC.
Okay.
I'm in the RFP portion.
Good.
With you guys.
Good. Good. We were doing HVAC all weekend. Turns out the dude that came over was a carrier tech for 10 years, which is cool because my machine's a carrier. And he was up there running it from the attic, which I thought was freaking cool. But what happened was the bearing started going, "Rrrt, rrrt, 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 rrrt," and he was checking the current flow, and the current flow just kept pumping up and up and up. It's like, yeah, bad bearing. So anyway, he figured out a way to get